Okie dokie. So containing without containers, which in light of the last couple of talks is literally the opposite direction. So just introduce myself. I'm Robert Tracey. This is my lovely job title in IBM. I think this is actually the shortened version of it because it goes on to like 2 or 3 lines for no reason whatsoever. I'm based up at Daresbury, which is near Warrington in the UK, which most people don't know where Warrington is. It's between Manchester and Liverpool, which everyone knows where they are because they produce the best football teams. And that's the round football, not that egg-shaped one that people play with. Okie dokie. So as I say, I'm part of IBM Research, so to give an introduction. IBM Research is based, we've got 12 labs across the globe, multiple Nobel Prize winners, Turing Awards, all that good stuff. And we have a history, quite a good history with supercomputers, going back from 1954 all the way up to Summit and Sierra at the moment, which are number 1 and 2 in the top 500. So that's just a very brief introduction of IBM Research, because we seem to get missed out quite a bit. Okie dokie. So I wouldn't read too much into this diagram, but we're looking at, most of the time now we seem to move into this data-centric way of working, where we've got our big data, on the other side we've got our traditional HPC, and we're coming together in the middle. Now, this is have we got laser? I'm aiming it the wrong way around, there we go. So this is the perfect world if you've got Docker or Kubernetes or anything else like that. So you can interact with all your traditional HPC with all this new data you're getting in. But if you're sat here with a traditional HPC, you may want to move into here, but there might be a lot of other external forces saying, no, you can't. So that's where this kind of talk kind of comes from. If you're sat here, what can you do to keep working? Okay, so what's wrong with containers? Simple answer is nothing. Great for scaling, isolation, platform independence, simplifying pipeline for developers if you're going for continuous integration, and many other reasons. They are a great tool and very, very useful, which kind of begs the question then, why am I here and why am I talking? There are a few downsides. There's various security issues with different bugs and root access things coming up at different points. It can be a slightly fractured ecosystem. I know we have various standards coming through, but you tend to buy into Docker or there's Java containers or Hyper-V containers. Trying to get them all to work together in your HPC environment can be quite difficult. And there's a definite overhead. Now by overhead I mean 2 things. There's a slight overhead on your system. I'm working especially with a lot of researchers who they want every last ounce of power out of the machine that they can get. And obviously if you start putting container software, you lose that. But also there's the overhead. Someone's got to go and update these things. Someone's got to maintain them. Someone's got to keep them going. You've got to keep that software. That's an overhead on someone. And obviously there's extra software which you've got to install to get that. So if you go down the Docker route, you've got to install Docker, which requires admin privilege usually. Depending on your cluster and your center and your rules, that might also include management permission, architect permission, project management, various forms. You could end up going up to director level, depending on what you want to actually install and change the cluster into. So the idea I've had takes its ideas from HA environment. So traditionally, I've only been working with HPCs for about 18 months. Before that, I worked with high availability machines in things like banks, government departments, energy, things like that. So in a traditional HA environment, you have to be up and running all the time. Banks get really upset if their online banking goes down, so they build these high availability environments. So in a traditional one, for those who haven't ever seen one, you have typically multiple servers. These can all be on the same site. They can be across multiple sites. It differs. And then you have all your applications which you kind of stack up underneath. So here we've got Apache. By the way, I'm quite traditional. When I say Apache, I mean HTTP daemons, usually not the whole Apache that it has now become. We can have Oracle DBs, we can have Java applications, things like that. And all your applications sit on these environments. And then the idea is, if you walk in Monday morning and server 4 has decided to go bang over the weekend and disappear off the network. You use your high availability cluster to shift one of these packages. So in this case, it was the Java. Shift it from server 4 and move it on to server 1. And in there's various clustering tools that you can use. There's Solaris, there's Service Guard, Red Hat has its own high availability clustering that shifts this over. And you can either set it to do it manually or automatic. One's the right way, one's the wrong way. I'll let you decide which one's which. And yeah, it just shifts it over. So how's that done in HA? So in HA, it's done, you can either do it two ways. You either install the application and libraries on every single server, and then just create disks or LUNs in this case that have just the data that makes that application unique, and you lift and shift and move that everywhere. That's a bad way to do it, and I would never ever recommend you do it that way because of update time. That'll kill you because you've got to update every single server. It's an absolute mess. You'll always find one server that's not right. So a different way of doing it is you contain all the code, libraries, binaries, everything you need on a single disk or LUN. And it's based on that idea of how you do it in HA, where you put it all on one single LUN, using that and putting it into a cluster. So how does it work and for what we tested it on? So I've used two pieces of software to test this. Both work quite differently, but both work. They just take a bit of different set of tools and different way of working to actually work. So I've tested here MongoDB, mainly because that's what our machine learning guys really, really wanted to use in our HPC cluster, but couldn't get a MongoDB instance installed. And also Apache. Again, I'm referring to the web server. MongoDB is great because it's really useful for the ML, big data, it's tunable, and most importantly for this, it has pre-built binaries, which makes it really, really easy. Apache Web Server is great if you want to show off your results. I'd say there's lots of add-ons now, and it's highly configurable. It does require manually compiling though to actually get it to work. So we'll have a quick look at that as well. So let's have a look at some code, because this is the interesting bit. You all see that, I hope? Okay, so I use LSF, so this is my LSF file, so I'll just walk through. So the top part is just standard LSF. You can ignore that. I just put it in there for completeness. The important parts are here and here. So all I've done is, so this is based on MongoDB and you having a single scratch area that is shared amongst all your compute nodes. So you untar your Mongo files that you've had, which includes, so I've got you can see here I've got the MongoDB and there's a bin directory that comes with that. And you basically start specifying some variables. So you're specifying your log directory, your database directory, and then your executable directory. And then the important part is how you actually run it. So typically with any piece of software like this, especially in Linux, it starts to scatter itself as soon as you run. If you run MongoDB from scratch, it starts installing its DB files where its default location is. It starts installing everything where it thinks it should do, which can be all over your OS, which is why you typically need admin privileges to do it. What I'm doing here is forcing it to use my scratch area. So we're using DB path here, it's what we set up above. Our log path, it's what we've set up above, all in my scratch area. And then I'm binding the IP to all available interfaces, so that when this runs on the compute node, it will be totally contained in my scratch area. So I can actually show you it running because I just copied and pasted various parts. So I use bsub to kick off my LSF script, which submitted it to the queue. And then I ran a bjobs command. Obviously, if you're using Slurm or anything else, you can do this differently. And you can see the node. This part's important. You will need the node bit a bit later on. But we can see that we've now got a database running. That job's actually running now on the servers. So then what I've done here, just to demo for you guys, is I kicked off an interactive session on one of our, we have interactive nodes, moved into my Mongo directory, and then just started a standard Mongo interactive session with the node number. Obviously, if you were doing some calculations that needed to write to the MongoDB or read from the MongoDB, you'd embed that node name actually in your code. You wouldn't be writing it here. This was just for examples. So here I'm running the Mongo interactive session, and you can see I connect to the database. and this works from anywhere on the cluster. So the benefits of using it MongoDB like that are there's no admin intervention, no request to install required. Any user can do this. Any user can be running Mongo, saves everyone time, and it allows the users to then just focus on getting on their data. They're not submitting a request that might get solved in a month or needs to go higher up the chain. There's no overheads for any other teams to maintain, and it allows them to use all of the node that they need. And it can also be shared, because one of the clever tricks with this is when you start up the MongoDB instance, it's your shared area, and you're the MongoDB admin. Every time you create users, obviously they have read or write permissions to the Mongo database. You set that in Mongo. That's just standard work in Mongo. If you hand those usernames out to other people in your team, other teams that have access to those clusters, if the MongoDB is up, they can access, as long as they're connected to the right node with the right port, they can access the data, they can write to the database if they have permission in the database. They don't need permission on your Scratch file system. So this allows you, if you have a single Scratch file system that you only have rights to, you can share it so that other teams can write and read from that area, which can be quite useful. Here, as I said, Apache is slightly different because Apache doesn't come pre-built for things like this, so you have to do it yourself. Again, the important parts are forcing it where you want it to actually go. So in this case, we're forcing it to go in my Scratch area again, and then it's just standard make install. And then I actually managed to get PHP to go along with it as well. So we built PHP, forced it into a location, forced and told it where HTTP was living this time, not to start searching the whole system. And then all it requires is 5 line changes in your HTTP conf file, and it knows it's running locally. And once again, we go to our LSF, and we can suddenly see that all we need to do is run it with our directory, and where the directory is. It is very important just focusing and telling it where it's living. By forcing it to and constraining it, it keeps it all in one area. So in summary, I think I'm doing well for time. Well, hey. Containers are great, but it sometimes can be better to contain without them. By using some of these techniques, you're using all the resources of Node. You're not requiring help from outside. Your users or yourselves can just go, get this installed, and get up and running with your whatever job you're trying to run. You're not having to align with a certain ecosystem. It's free to move anywhere else. And you've also gained the ability to share your work and your findings with other teams, or within your own team as well. I have to include that this was work was supported by STFC, Hartree Centre, which is where we are based at the moment with IBM, as part of the IRO project based in the UK. And there's a lovely picture of my office, which I was told I have to include, because I have to advertise that if you'd like to work with us on anything, these are the people who you need to talk to, not me. I don't have that power. So, any questions?
I mean, you use like a batch scheduler here because you have to work with the constraints that the system provides you, right?
Yeah.
How is it just a project, or is it something that's used as well, or is it just to try out so how you can use batch schedulers to schedule service workloads? No,
the batch scheduler was there first. This was to be able to get our stuff to work with the batch scheduler because that was already there already. Yeah.
So it's used for in the hardware, the center that you.
Yeah. We use LSF. We have 2 or 3 clusters, and all of them are running LSF batch scheduler.
Okay, interesting.
So you're running a Mongo instance per user? Is that in your configuration?
That is the possibility, yes.
Okay. And then for Apache, you're doing the same?
Yes.
But you're not, okay. So you're running basically just separate instances of every service for every user?
Yes, because it's easier in some ways than getting them to create them somewhere else. There is the possibility, So it's recommended you run in exclusive mode when you're doing this. You have that node, because otherwise you can cross in ports and things like that with your daemons. But alternatively, you can manually set all the ports as well. I'd recommend you using UIDs from the users, because that's as unique as you're going to get.
How are you doing application level security for the ports that you open up on the HPC system?
That's kind of down to the application. And so it's down to whatever the user installs. Are we talking that level, or are we talking OS level?
I'm saying, like, if I want to connect to the MongoDB instance, how do you, I mean, we would never allow users to just open a bare port at our HPC center, because then someone could just steal their data.
Yeah.
Right? And so, like, we have some mechanisms in place for this stuff, but, you know, it's fairly tightly controlled by the center. And like, for the Apache case, we deploy a lot of services so that they actually just set UIDs to users. So like we use the Apache set UID model.
Yeah.
And then the CGI processes that users want to run actually run as them on the system. So I guess, like, how do you balance this approach with, you know, the actual, I mean, I don't know, the nice thing about containers, right, is that when you virtualize the network, like, you can actually limit who connects to who.
Yeah.
But in this model, it doesn't seem like there's any network security in it. So what do you propose to do about that?
That's something I need to look into. I'll be honest, at the moment our clusters are very contained. We use a multi-cluster environment, so you have to get to a login cluster before you actually get to the main cluster. So it allows us to be a bit more flexible with our networking, because it is totally isolated. But it is something, yes, that we are looking into as well, is how we can secure it in between all the different nodes.
Okay, no more questions. We can stop for lunch now, so lunch is ready outside.